Hello, students. Welcome to another moment of science. Today we are talking about magnets. We are going to do a lab about how distance affects the amount of force that two magnets have. Okay, so your hypothesis question today is, how does the magnetic force between magnets change as the magnets get farther apart? Okay, remember, hypotheses should be written as if-then statements. If this happens, then this is going to happen. So what you need to do is you need to pause the video and write an if-then statement to answer that question. How does the magnetic force between magnets change as the magnets get farther apart? You could start it by saying, if the magnets get farther apart, then what do you think is going to happen to the magnetic force? Right, so pause the video right now and write that hypothesis. Today, we have a couple of things that we're going to be using. We're going to have our spring scale that we've used in the past. We have a magnet on a string. We have a magnet inside this block of wood. Remember, wood is not magnetic, but there is a magnet inside. And then we have some spacers. Each spacer is 1 millimeter in depth. So that will be our distance that we're measuring. Okay. Remember, by now you should know that magnets either attract or repel each other. So a good example of attraction would be that. And if I flip this magnet over, you can also see repelling, which is pretty awesome. You can see that the magnet will not touch each other. It's pretty cool. All right, so what we're going to do is I'm going to start off by putting all 8 of these spacers on top of the magnet that's in the wood. I'm going to hang this magnet from the string, and I'm going to see how much force it takes to separate the two magnets, and then I'm going to write it down. I'm going to do each trial 3 times to make sure that I have good data. Remember, every good scientist measures everything more than just once. Okay, so do that once. Twice. And 3 times. Then, just like any good scientist with their data, I'm going to find the average of those 3, and I'm going to put it somewhere on this video. All right, then I take one spacer off. Remember, each spacer is 1 millimeter in width. And I'm going to measure. Okay. Do it again. And one more time. There we go. And here's the average for 7 spacers, or 7 millimeters. And here we go for 6. Okay. Again, I'm doing all these 3 times in a row to make sure that I'm getting good, accurate data, and we don't have just one piece of data that might be completely wrong. Here is the average for 6 spacers, or 6 millimeters. Okay. And here we go for 5. You should be seeing a pattern so far. Correct trial 2. And trial 3. And here's the average for 5 spacers. Now we're halfway through. Now we have 4 spacers. Okay. and here's the average for 4 spacers. And now we go on to 3 spacers. You'll notice that when I did it that time, the block of wood started to lift up. That does not help us, so I have to start holding the block down. So that should give you a pretty clear indication of what's happening with the force. Is it getting stronger or weaker? There's 3 for 3 spacers, and here's the average for that one. All right, here we go for 2. You might have noticed a little bounce in the spring scale this time. That is because of one reason. And you should be able to tell me what that reason is based on the evidence that you're being given. Okay. Here's the average for 2 spacers. All right, now we have 1 spacer left, and then I'm going to do it with no spacers to show you what happened then. Okay. All right, so 1 spacer. Went so fast I didn't get it. All right. Got it. That's a great thing about science. If it doesn't work the first time, you can always try it again, just to make sure it does work. Okay. And one more time for good measure. All right, and here is the average for just 1 spacer. And here we go. Last one, no spacers at all. These are the spacers that are attached to it to cover up the magnet, so they don't count. All right, 0 spacers. Here we go. Interesting. Let's put this thing back on here. Figure out what happened. Trial 2. And finally, with 0 spacers or 0 millimeters. And here is the average for 0 spacers. Okay, so with the data that you've gotten from this lab, please answer the conclusion questions. When you're making your conclusion, please restate your hypothesis. Tell me whether you agree or disagree with your original hypothesis, and give me evidence from this lab to prove whether you were right or whether you were wrong. Okay, and then use the evidence that you've given to answer the last couple questions. Thank you, and I can't wait to have another moment of science with you.